Alrighty, in this video we're going to be looking at equivalent fractions and what does that mean? How do we create them and therefore how do we use them in order to simplify fractions down to their most basic form? It's a Year 8 content descriptor, and so this is primarily for my Year 8 class, but any Year 8s or anyone around the world in any level of mathematics who this helps, I hope it does. So before I actually start just telling you what to do in order to simplify, I want to look at what is an equivalent fraction and how is it created so that we gain a better understanding of why we do what we do. Because it's all well and good for me to make this video and say do this, but unless you have the background understanding of why, it's not going to be so useful. Okay, so looking at these equivalent fractions here, I'm going to use the context of pizza because who doesn't love pizza? If I draw two pizzas here, that's actually a remarkably good freehand circle, if I do say so myself. And if I cut this guy into 4 slices, okay, very large and generous slices, and I'm going to say I get 2 of those slices. You can have the other 2 because I'm generous. So I'm going to shade in the bits that I get. And if I look at this pizza and I create a fraction for this, I get 2 out of a possible 4 slices of pizza. So I get 2/4. If you want, and you're probably switched on enough to think about this, how much of the pizza is that? We know that that much of the pizza is 1/2 of the pizza. We don't usually think of it in terms of 1/2 slices, but we do think of it in terms of a half. I get half the pizza, you get half the pizza. And straight away, we can see then that 1/2 is equivalent, or it's almost got equal in it, doesn't it? Not quite equal fractions, equivalent fractions, because while they look different, they represent the same thing. Okay, I'm going to draw one more pizza, probably not as successfully round as the first one. Yes, not as good, came out a little lumpy, but that's fine. I'm going to cut this pizza into 8 slices. So halve it again, and then halve them. Okay, so I've got 8 slices of pizza now in total, but I still want half the pizza. Okay, so what I'm going to do is I'm going to shade in the pieces that I get, and you can have the rest. So I get this one, this one, this one, and this one, and that's about half the pizza there. If my drawing was perfectly circular, it would be. And if we count the slices I get 4, but there are a total of 8 slices in total. So what's happened here? I'm still getting half the pizza. Initially I was getting 2 out of the 4 slices, and that was half, and now I'm getting 4 out of the 8 slices, and that's half. So what I want you to see is that these 2 pizzas, the amount of pieces that I'm getting, they're equivalent to one another. Okay, they're not equal because these pizzas are smaller, and I have more of them, but in terms of how much pizza I get, they're the same thing. So they're not equal, but they are equivalent. They mean the same. So they look different, but they mean the same. And so what I need to ask myself is, well, if I'm not thinking about pizza, if I'm just thinking about fractions, how do I get from here to here in pure mathematics? Well, all I have to do is realize that I have doubled, or times by 2, the amount of slices that I have in total. So what I've done is I've taken the amount of slices, 4, and I've doubled it. I've turned it into 8 slices. So I've taken this 4 and I've times it by 2. But because I want an equivalent amount of pizza, I also need to get double the slices. If there is twice as many slices, I need double as many to have the same amount. So I've also taken the numerator 2 and times it by 2 in order to turn it into 4 slices. Okay, so hopefully we can agree by pizza diagram that 2/4 is equivalent to 4/8. They have the same value. They look different, but they have the same value. Okay, and also they both mean a half, which is as simple as it gets. I'm using this logic because when it comes to actually simplifying these problems, we use the reverse of this. So in this instance, I was making the fraction bigger. Okay, I was making it more complex because 4 and 8 are larger numbers than 2 and 4. So in order to take 4 and 8 and reduce it to 2 and 4, or to simplify it, I do the opposite of times by 2. So to go from 4 over 8 to 2 over 4, I would divide both top and bottom by 2. Okay, so we're going to use that concept over here. So we're going to transition over here now. In this fraction, I have 12 and 16. And one of the biggest challenges in simplifying fractions is actually finding out what numbers go into your fractions, into the numerator and the denominator. In this one, we can see that 2 goes into 4 and 8. So does 4. So does 1. 1's kind of a number we ignore for now. So looking at this one, they're both even numbers. So worst case, I can halve them. Okay? And I'm just going to, spoiler alert, 4 goes into both of those numbers. 4 goes into 12 3 times, and 4 goes into 16 4 times. But let's pretend that I'm still building my capabilities with fraction simplification. What I want to show you is that you can get there the long way. Even if you don't straight away see the biggest number that goes into both, you can get there the long way. So I see that they're both even, which means they both are divisible by 2. 2 goes into both. So what I'm going to do, using my pink highlighter here, is I'm going to divide the bottom by 2 and divide the top by 2. And when I do that, I'm going to get a fraction that says 16 divided by 2 is 8, and 12 divided by 2 is 6. Okay, this is looking more reminiscent of my pizza now, except instead of 4 slices, I'm getting 6 of them. Excellent, that's good for me. But we can, of course, simplify this guy one step further, because again, they're both even. So, okay, I'm going to divide them both by 2 again. So that's going to equal, just checking my fraction still on the screen, it is good. I'm going to divide by 2 again, on the top and the bottom. And I get 6 divided by 2 is 3, and 8 divided by 2 is 4, and I get 3/4. That's pretty cool. I'm going to use a different color here and just show, okay, you don't have to do it in 2 steps. You can do it in 1 step. It's just whether you've developed those capabilities and whether your factor identification is good enough. But like I said at the top, divide by 4 and divide by 4 is possible. So we can, in 1 step, just divide by 4. And also, this is going to be a bit tricky to navigate here, but if I also divide that guy by 4, so 12 divided by 4 is 3, and 16 divided by 4 is 4. So it'll save you time if you can see that 4 goes into them straight away. But if you can't, like if you just go, okay, they're both even, I'm going to start there. You notice that it took me 2 steps, but I got there in the end. So whichever method you choose, or whichever method you're capable of, go with that, okay? Now, this one down here. Not both even. So I have to use a different strategy. I can't just halve them both. One thing I do know about divisibility is that, or multiplication really, if I count in 5s, 5, 10, 15, 20, 25, 30, 35, 40, and so on, all of those numbers, all of the multiples of 5 end in 0 or 5. And both of these numbers end in 0 or 5, which means that both of these numbers are divisible by 5. Now, 5 may not be the biggest, maybe 15 goes into it, maybe 25 goes in, but at the very least we know 5 does. So that's where we're going to start. So, same strategy. I'm going to divide the top, or the numerator, by 5, and the denominator by 5 also. And I'm going to get 25 divided by 5 is 5. And 70 divided by 5, well, that's 14, but a good way to figure out that it's 14 is say, well, 5 goes into 50 10 times. I can't hold up 10 fingers while I'm holding my pens, but 10 times 5 goes into 50. 5 times 10 is 50. And 70 is 20 more than 50. 5 goes into 24 times, so it must be 10 plus 4, which is 14. However you do it, it's going to be 14. Even if you count in 5s and go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, that's 14. So 5 into 14. But I better check, because I need to make sure that this is the most simplified fraction that I can get. So both aren't even, so that doesn't work. And 5 is actually a prime number, which means that it is only divisible by 5 and 1. And so all I have to check really is 14 divisible by 5? No, it's not. 5, 10, 15, it's one too many. And so 14 is not divisible by 5. And so that's as simplified as that guy gets. Okay. I hope this helped. I hope these two examples helped. If you need any more help, please just leave a message in the comments with a specific problem, and I'll either message you back or I will create a video about it if I think it's video worthy, I suppose. Hope the pizza helped. Remember how good I am at drawing circles, and I'll see you in the next one.